Hello everyone, my name is Sorab Lutfi and this is my ninth video on learning chemical biology. And today we are going to talk about from molecules to ecosystems. Interactions are important in biological systems. And so let's start our video. At any level of the biological hierarchy, interactions between the components of the systems ensure smooth integration of all the parts, okay, such that the functions function as a whole. Okay, this holds true equally well for molecules of a cell and the components of an ecosystem. And I'm just going to talk about one of them in this video because if I put them all in one video, the video will get very long. So I recommend subscribing to see my next video. Okay, so let's learn about molecules, interactions within organisms at lower levels of organization. The interactions between components that make up living organisms, for example organs, tissues, cells, and molecules, are crucial for their smooth operation. Okay? Consider the regulation of blood sugar levels. Okay? For instance, cells in the body must match the supply of fuel to demand regulating of the opposing processes of sugar breakdown and storage, or simply the cell's demand for food. Okay? The key is the ability of many biological processes to self-regulate by a mechanism called feedback. In feedback regulation, the product of a process regulates that process. Okay? The most common form of regulation is in living systems is negative feedback. Okay? A loop in which the response reduces the initial stimulus. Take for example the signaling of insulin. Okay, as you can see over here. Okay, over here. After a meal, your blood sugar or blood glucose rises, which is stimulates the cells of the pancreas over here, insulin producing cells in the pancreas. Okay, to secrete insulin. Okay, insulin, in turn, causes the body's liver cells to store the glucose, and it acts as a key that can cause the body's cells to take up glucose, thus decreasing blood glucose levels. Okay, and the decrease of the blood sugar elements eliminates the stimulus of insulin secretion, and thus shutting off the pathway, and so the output of the process negatively regulates that process. Okay, as you can see over here. Okay, now let's talk about positive feedback. Okay, though positive feedback is less common than negative feedback, but there are also many biological processes that are regulated by positive feedback, in which an end product speeds up its own production. Okay, for example, the clotting of your blood in response to injury. When a blood vessel is damaged, okay, as you can almost see in this picture, okay, structures in the blood called platelets begin to aggregate, as you can see over here. These round-shaped cells are aggregating or accumulating at the injury site, and positive feedback occurs when the platelets release chemicals that attract more platelets. Okay, as you can see here, there are just a few platelets on the over here, but after they produce that chemical, all the platelets come and just attach or accumulate on the injury site to so that they can successfully stop bleeding from the vessel. So the molecule attracts more platelets. The platelets pull up then initiates a complete process that seals the wound with a clot. Okay, so that was positive feedback and negative feedback, and next time we are going to talk about the interactions of the components of an ecosystem with each other. Okay, so I'll see you in the next video.